1.3 Fraction Review. A lot of people are afraid of fractions, so I start my class out, my face-to-face class, by asking the class what they remember about fractions, and they start calling out things like denominator, or numerator, or KCF, maybe mixed numbers. And so we get started talking about fractions because it seems like a lot of people, not everybody, but a lot of people have a fear of fractions. And so we're going to go through a review. It is important for you to know how to handle fractions and the things to remember about them. But really, with fractions, it's all about the rules. You've got several rules, and they apply to very specific things. And so if we will keep the rules straight, it will make everything a little bit easier. So let's talk about adding and subtracting. This is when you need a common denominator. I didn't say least. Least is nice because it's less work at the end with the reducing. But we don't need a least common denominator. We just need a common denominator. If we have 1/2 plus 1/3, I need a number that both of these will go into. And so if I take those two and multiply them, I can get a common denominator. And in some cases, it will be the least common denominator, like here it will be. Then I have to make equivalent, and all that means is equal fractions. To do that, I'm going to ask myself, what do I multiply times 2 to get 6? And we multiplied 3. So 3 times 3. So 3 times 1 is going to give me 3. Now this 3 over 3, it equals 1. So the value of the half doesn't change. 3/6 is still half of something. It's just in more pieces, because that's what the 6 tells us. We have 6 pieces. Here we have 2. So it doesn't change the value, it just changes the look. But if you change the denominator here to something else, you've got to change the numerator. So then we want to look at 3 times 2 is how we got the 6. So 1 times 2 will give me 2. Then I can take and add everything together. We've got 3 plus 2 will give us 5 over 6. Something else you may remember about fractions is they must be reduced. Or simplified is another word. So when we look at this number 5 over 6, then I know this is reduced because 5 is prime and it won't go into 6. So it can't get any smaller. But we always want to ask ourselves that. Let's look at some adding some more fractions. when we look at 2/5 plus 1/3, if we can't, 5 and 3, they won't go into each other, but if I take and multiply them, I'll have a common denominator. And in this case, it's the smallest. So 3 times 5 is how we get the 15. So it's 1 times 5. 5 times 3. 2 times 3. Then I can add the numbers. I want you to practice with this. Let's see. I want you to go ahead and practice now. This is a review. We're going to go through the chapter 1 sections very quickly. So this is a review. So I want you to go ahead and practice. And what we're going to do is I am going to work while you work. I'm going to ask you to pause the video. We'll write the problems down, and then we'll pause the video. Okay, now I'm not actually going to pause my video. I'm going to keep working. But I want you to write these down, and I want you to pause. And work out the problems. And then turn the video back on and check your answers. So we're going to use 8. 4 will go into 8. So we always want to use a number that's there if we can. Less work. 4 times 2 is how we get 8. So 1 times 2. This 8 didn't change, so the 5 doesn't change. Add them together. 7 is prime. Won't go into 8, so I know it's reduced. Here I'm going to use 35. Five times 7, 2 times 7. 7 times 5, that's how I get that 35. 3 times 5, so that equals 1. Not changing the value, just changing the look. Then I can add, and again, I would have a reduced number. Here, use that as your denominator. We're going to leave it improper. Okay, so I hope you got all of those. You'll have quite a bit to practice on. This section is quite long, so we're going to have a lot of things that we're going to cover. So let's just go ahead and move on. We've got to reduce these. Now, all of the ones that we just did were reduced. So let's look at reducing. And we're going to use prime factors. And so we're going to look at a couple of different ways to do this. You've got the guess and check method. And this works most of the time, but you may have to check it several times. So you're really guessing. So if you have a number like 24 over, let's say, 27. Well, nope, that's not a good example. I want something else. Here we go. Let's do 28. Everybody's going to see that those numbers are even. So they'll say, well, you can divide that by 2, the top and the bottom. When we're reducing, everything's going to get smaller, so we're dividing, but notice the 2 over the 2 still equals 1. We're not changing the value, we're just going to change the look of this. 24 divided by 2 is going to give me 12. 28 divided by 2 will give us 14. When you look at this, this is where the check part comes. 12 and 14 are both still even. So we'd have to do it again, the division. So divide by 2, divide by 2. So now I have 6 over 7. 6 isn't prime, but 7 is. And that's a pretty good indication that your number is reduced. Not all fractions that are reduced will have a prime number in them, but if they do, that's a good flag, a good warning that it more than likely is. But you always have to ask yourself, will it go into the other number? That's one method. The other is using divisibility rules and prime factorization. Alright, with the divisibility rules and prime factorization, let's go ahead and look at the rules first. We'll need to do this just so that you'll have them and to be able to use them. It's very helpful here when you have to do prime factorization. I found that if I write in cursive, it makes less of that clicking noise. A number can be divided by blank if, well, I don't want to write blank, I want to, there we go. And we're going to have a list of a few numbers here. And these are the divisibility rules. A number can be divided by 2 if it is even. And remember, even numbers end with 0, 2, 4, 6, or 8. 3. A number can be divided by 3 if the sum of its digits can be divided by 3. So if I look at a number like 6, 12, and I want to know if I can divide 3 into this, I will just take an add. Oh, kind of making a mess of that. 6 plus 1 plus 2. That equals 9. 9 can be divided by 3. So that means this number can be divided by 3. Very helpful. 4. A number can be divided by 4 if the last 2 digits can be divided by 4. So in this number 612, if I look at the last 2 digits, 12 can be divided by 4. So that means the whole number, 612, can be divided by 4. 5 and 10 you probably know. You probably knew too. 5, if the number ends with 5 or 0. 10, if the number ends with 0. 9 is about the same as number 3. So you're not really having to learn a whole lot of rules. You should know the 2, the 5, and the 10, even if you haven't really thought about it like this. 3 and 9 are very similar. Well, try that again. The sum of its digits divide by 9. So this number is 612. Because when we add up the digits, we get 9. It can also be divided by 9. Because 9 can be divided by 9. 6 is, a number can be divided by 6 if it can be divided by 2 and divided by 3. These are some handy little rules to have. So you ought to stick these on a 3x5 card. A 3x5 note card would be a good idea. Now let's look at how we can use this with prime factorization and how we use these to reduce large fractions. What we're doing with the guess and check, we're going to do that with smaller fractions. We're going to have to use this with large fractions. Alright, so let's talk about prime factorization. And first I want to talk about a couple of words. Prime and factor. Let's look here. Let's do factor first. Factors. Numbers that are multiplied. Two times 3 equals 6. These are the factors. 6 is the product. Prime. Prime numbers have 2 factors. And we just said factors are numbers that we multiply. 1 and itself. Or I guess I should say a prime number has 1 in itself. So if we look at a list of prime factors, we would start with 2. That's the only even one. The rest are odd. But not 9. Because 9 is 3 times 3. And 1 times 9. For it to be prime, it can only be 1 times that number is how we get it. 11 goes here, 13 goes here, 15 does not, because we can do 3 times 5. 17, 19, 23, 29, etc. Want a longer list? Go to the internet and Google prime numbers and you can get a list. Or look in your book. You can get to your book online when you go to Course Compass and do your homework. Okay. Let's see how this works with reducing. Well, first let's do the prime factorization. You probably know it as a factor tree. So let's look at 36. There are several ways to start 36. We could start 4 times 9, or maybe 6 times 6, 18 times 2, 12 times 3. Let's do 12 times 3. Keep going, and when you have a prime number, we're going to circle it. So 4 is 2 times 2, and those are both prime. 9, 3 times 3, and those are both prime. So the prime factorization is 2 times 2 times 3 times 3. If we're writing it just for prime factorization, we would use exponents to shorten it. But for what we're going to do, we're going to leave it expanded. It doesn't matter how you start the factorization. We'll end up with the same number. When I break this down, it's 2 times 3. Those are prime. 6 is 2 times 3. Those are prime. If you circle it as you go, it's easy to see the numbers when you go to write them out in the prime factorization. 3 is prime, so we circle it. 12, we could do 2 times 6. That's prime. 6 is 2 times 3. And again, there's 2, 2, 3, and 3, just like we have. All right, let's look at how to use this to reduce large fractions. Let's look at 312 over 546. We're going to do a factor tree for both. The divisibility rules will help me get started with this. Now they're both even, so I could start with 2. That would be a good place to start. But this one, 12, whoops, what happened to my 2? The 12 could be divided by 4, so that means the whole number. Or 3, 4, 5, 6 could be divided by 3. So I could start with 2, 3, or 4. Or a combination of that, because the 2 and the 3. So the 2 rule, yes. 3 rule, yes. 4 rule, yes. And if the 2 and the 3 are a yes, so is the 6. So I could start with any of these numbers here. If I start with the 2, I'll end up with a little lopsided tree, but it won't matter. If I start with the 6, it'll be more even, but again, it won't matter. We'll end up with the same number down here at the end. I'm going to go ahead and start with 3. I think it'll be easier to divide just without having to actually come over and do the work, do it in my head. Alright, so 3 times 104. Then that ends with a 4, so I know I can divide 4 into that. Alright, 4 into 10 is going to be 2. That's 8. Remainder would be 2, so 24. So 4 into 24 would be 6. This is prime. Keep this coming. 2 and 2, those are prime. 26 is even. So I can divide it by 2. 2 times 13. So there are all my prime numbers for 312. 546. Let's see. I can do the 2's. 3. That's 10, 15. Could do 3. 4 will go into 46. No. 5, no. 6, yes, because these two are a yes. 9, no. 10, no. So I could start with 6 again, or with the 2 or the 3. So I think I'll start with 6 this time. Kind of do me a little squiggly line to keep it out of the way. 546. Now, I may have to grab my calculator and divide that, or come over to the side. 546 divided by 6 is 91. Well, that can get smaller. And those are prime. Can 91 get smaller? Is it on your prime list? I don't think it is. It can't be divided by 2. Can't be divided by 3. 9 plus 1 is 10. Can't be divided by 4, 5, 6, 9, or 10. Well, there is a number here that we don't have in our list, and that's a 7. And when something ends with a 1, I always think about a 7, or maybe a 17, or even a 13. We don't have divisibility rules for these. And then when I look over here, it may not be 7, or it might be 13. But let's try 7. So let's see, 91 divided by 7. Yep, will give me 13. So all my prime numbers. So we'll come over here. $312 is 1, 2, 3 2s, a 3, and a 13. That is the prime factorization of that number. 546 is 2 times 3 times 7 times 13. Then we cross out top and bottom. Remember, 2 over 2 is 1. 13 over 13 is 1. 3 over 3, it's gone. Take what's left, 2 times 2, and then the 7. We could have done the guess and check. You probably own a calculator or a phone with one. It might take you a while, but this is a good way to do it with bigger numbers, because you're going to get, as long as you do the factoring right, you'll get the right number. Okay, let's go ahead and look at mixed numbers. Mixed numbers. Something we want to remember is we must change to improper to add or subtract. No, what am I saying? We must not change to improper to add or subtract. We do that to multiply or divide. Now we're going to multiply or divide in a little bit. Let's add or subtract first. That's what we did with our fractions. Then we'll go back and we'll look at multiplying for both. Mixed numbers must not change to improper to add or subtract. It wastes time. Let's look at 3 1/2 plus 2 3/4. I need a common denominator. 2 will go into 4, so we'll use 4. This fraction doesn't change. Here we multiply 2 times 2 to get 4, so 1 times 2. Now we can add. 2 plus 3 is 5. 3 plus 2 is 5. But I cannot have a mixed number inside of my fraction. So we're going to change that. To go from an improper fraction to a mixed, we divide. 4 goes into 5 one whole time. Your remainder. So the 1 comes here as the whole number, and the 1 remainder goes at the top, and your denominator is the same. Then we're going to take the whole number we had and the new number that we have here for our fraction and combine them. Let's look at subtracting with mixed numbers. I think we'll use the same number. We already saw our fractions, our equivalent fractions. Nope. Now we are subtracting, but I can't take 3 from 2, so I am going to borrow. And I'm borrowing a whole 1 from the 3, so it now becomes 2. But I'm going to write this 1 as a fraction with the same denominator as these two fractions. So we've got to make a denominator of 4, and if I have a denominator of 4, the top has to be 4 for it to equal 1. Then we're going to take the number that we already had and the number that we borrowed, and we're going to add those together. And we're going to get a new number of 6 over 4. Now we will take these two numbers and subtract them. 6 minus 3 is 3/4. 2 minus 2 is 0. Now we don't write the 0, but we know that's what it becomes. Okay, I want y'all to practice with this, because it's probably been a while since you added or subtracted. So what we're going to do with practice, you're going to want to write the problems, then pause the video, work the problems, start the video again, and check your answers. We'll be doing this all semester. I like for my students to practice while we go along so they can try out the new things, or just this, like I said, this should be a review. Hopefully this is really easy. Many of you probably are not even watching the video. You're probably already trying the homework, but I hope you are watching it and learning and reviewing. All right, let's look at do 6 1/3 plus 2 5/7, and we're going to subtract the same thing. Make it a little easy on you so you don't have to do equivalent fractions but once. Okay, so go ahead and work both of those out. Write them down, pause the video, work out the problems, then start the video again. When you come back, they will magically be there. Okay, how'd you do? All right, well, check your answers. The borrowing is what my students have the hardest time with. You borrow 1, you change it to a fraction, same denominator. Take what you borrowed, what you already had, add them together to get the 28. Then you can do the subtraction. All right, let's look at how we're going to multiply and divide. We're going to do fractions and then we'll do mixed numbers. Multiply straight across. Reduce if you can. Sometimes you can reduce first with what we call cross-canceling. See, both of those numbers can be divided by 3. 3 divided by 3 is 1. 6 divided by 3 is 2. Then you can multiply. 2 times 2 is 4. 1 times 7 is 7. And so you get your reduced answer. Now you can go ahead and multiply first if you wanted to. If you have 2/3 times 6 over 7, 12 over 21. But then here you need to recognize that this is not reduced. So if you want to reduce, they're small enough to do guess and check. They both can be divided by 3. 7's prime. 4 doesn't go into it, so then you know that that is reduced. But either way, you've got to reduce. Either do it before with the cross canceling or after with the guess and check. If it's a really large number, then use that prime factorization method. Let's look at with division. Division just becomes multiplication. And at the beginning I mentioned that KCF, it's keep the first fraction. Change to multiplication and flip the second fraction. Two-thirds, let's say, divided by 4/5. Keep the first, change it to multiplication, reciprocal of 4/5, 5/4. I'm going to cross cancel. 2 divided by 2, 4 divided by 2. 3 and 5 are prime. When I finish, I have 1 times 5, 3 times 2. I've already done the reducing. Unless I miss something, because sometimes a number will be on top and bottom that can be reduced, and I might miss it. But 5 is prime and it doesn't go into 6, so I know that I'm finished with that. With mixed numbers, multiplying or dividing mixed, here is you must change to improper. We didn't have to do it with the adding and subtracting, remember? Here we must. 3 1/2 times 2, and we'll say 1/3. Multiply these two. 6 plus that one, 7 over 2. Multiply 6 plus 1, 7 over 3. Multiply straight across unless you can do some cross canceling. I have 49 over 6. And then change back. So 49 divided by 6. Whoa. Sorry about that. Oh, sorry, I don't know what I touched. That'd be 8, 48, 1. So we're going to have 8 1/6. Okay. Division. Let's look at this. Change it. 41 over 8 divided by 8, 9 over 4. Keep. Change. Flip. These two can be divided by 4. And then I'll have 41 over 18. Come over here and do the math. Let's see. 2. Give me 36. 5. So this is going to be 2 and 5 over 18. Alright, I know this is a lot of information in one section. Most of your sections are not going to be this long. I try to break them up into smaller bits, but for what we're doing, we hit the highlights of all your adding and subtracting and multiplying and dividing of fractions. So let's just kind of wrap it up with a little note, because I started out by saying it's all about the rules. And they don't intermingle. They don't really change. So with adding and subtracting, you got to get that common denominator. But you don't do it with anything else. With multiplying or dividing, you can cross cancel. But not with adding and subtracting. With mixed numbers, if we're adding or subtracting, don't change. If we're multiplying or dividing, change to improper. Always reduce. I find the biggest mistakes happen here. People want to get a common denominator when they're multiplying, or they want to cross cancel when they're adding or subtracting. So if you'll keep these straight, then you'll probably have less problems. The other problem runs into when we're making our equal fractions. So just be careful. The bottom changes, so does the top. Alright, I'll see y'all, or I'll talk to you later. Bye.